All right, good morning. We are going to look at the concept that I taught yesterday about dilations. And dilations are a way of changing a figure, making it either smaller or making it larger. So I'm going to go to the definition first. It says dilations can either be an enlargement, making the figure bigger, or a reduction, which makes the figure smaller. The scale factor describes how much the figure is enlarged or reduced. And that scale factor, I'm just going to throw this out here, is expressed as a ratio. Okay, so the scale factor is a ratio, and is the ratio of the image. So, like the new side length of the image to the side length of the original. And I'll show you up above in our example how that works. Okay, so we can find it. It's a ratio of a dimension of the image over a dimension of the original. Okay, so we're going to go ahead and take a look at this. And so as part of this, I want to talk about a couple of things here first. Notation. So notation, we have, you notice one of the triangles, so triangle ABC. And then we have, it kind of goes, and we end up with a new triangle, and that is triangle A prime, B prime, C prime. So there's little dots there. Oh, I forgot my little triangle there. Okay, so what I'm looking at here are comparing this. So you see here that we have these little dots right there. They're little apostrophes, and we call that prime. So what that's saying is that this is the original, and this is the image. It's the after. What did we get after we, in this case, enlarged it, made it larger? Okay, so those little symbols tell us then, without them telling you anything, you could look at a diagram and know which one was the original, the one without the little prime symbols, and which one was the image. So again, we call this the original, and we call this the image. Okay, and so the process to get there was a transformation called a dilation. Okay, in this case, an enlargement. Okay, so that is the basics there. So I want to compare something. So let's look at the side lengths. So our side length here on BC, we're starting at -1 and we're going to 2. So it's a 1, 2, 3. So the side length is 3. So I'm going to talk about BC. That is the side length. And I want to look at how it compares to its image, which was, if you follow the markings, B prime, C prime. Okay, so our original was a length of 3. So let's go ahead and count out how much the new image is. 1, 2, 3, 4, 5, 6. If we know and can tell what that is, and we can figure out what the scale factor was. So it's not just, oh, look, it got bigger. The question is by how much. That's what the scale factor would answer. So our scale factor then, our scale factor is a ratio of the image over the original. So it is 6 over 3, and that gives us 2. So you can say, oh, look, the image is bigger. And someone says, by how much? And you would say 2 times. It's 2 times bigger, or a scale factor of 2. Now, what you're going to notice in some cases, the scale factor is indicated with the letter K. So in this particular example, we'd say K equals 2. That's saying scale factor is 2 without having to write scale factor a bunch of times. So if you see something that says, oh, k equals 2, oh, that's the scale factor. I'm just going to double all the dimensions. Okay, and so that's how that works. All right, so we go down here now. Shapes which are dilated are similar. That is a big deal. Okay, they are the same shape. They are not the same size. They are not. Their angles are congruent. Their sides are proportional. So that's kind of a big deal, and you'll see that. That will be the answer in a lot of questions. All right, I want to talk about that scale factor. Okay, so that scale factor is kind of a big deal. So scale factor, we already talked about what that is. We're using the symbol K, lowercase k, to indicate that. Okay, and so I want to talk about a couple of things. First of all, if that scale factor, K, is greater than 1, then the transformation, or dilation in this case, is an enlargement. The figure will get bigger. Okay, and in the case up there, 2 was greater than 1 and our image was bigger. If the scale factor is less than 1, if the scale factor is less than 1 and the scale factor is greater than 0, so basically between 0 and 1, then it is a reduction. Now, so we had some examples, and they were on a grid. They were on, well, you can see it up here. So we're going to go back up to here. Okay, and we had that on a coordinate plane. So I want to take a look at that. Okay, I want to take a look at what's happened to the coordinates. So up here, when we look here, let's look at C. So C is 2, -1. We performed a dilation of 2. Let's see what happened to those. We take a look at here, and it's 4, -2. So not only do the dimensions, the sides, multiply by 2, the actual coordinates themselves multiply by 2. So to figure out where the new C point should be, I'm going to take those coordinates, 2, -1, multiply each one by 2. So times 2 times 2. 2 times 2 is 4. Well, -1 times 2 is -2. And that is the coordinate of our image, the image of C. So the original C is at 2, -1. Multiply them by 2. The coordinate of C prime, the image, will be 4, -2. And so, what that does then is it gives us that new point that would give us the image that is enlarged by a scale factor of 2. So there's a way we can write that in a generic way. Okay, so if k equals 2, then that means that I'm going to write down x, y. So here is an image point. Okay, we'll call this A. So if the point A is xy, then the point A prime will be kx, comma, ky. So you're just taking that scale factor and multiplying it by each, the x and the y. Okay, so if I look up here then, so we could write this as C as 2 times -1. And so we'd say that C prime is 2 times 2, -1 times 2. So we're just multiplying it by that scale factor. Here's the scale factor. Okay, and so that's what a lot of the work in Big Ideas Math was. The first set of problems where you had to graph, they gave you a scale factor of 3. Multiply all the coordinates by 3. And the second set, they indicated each problem was a little different. One of the problems was 4, k equals 4. Another of the problems was 0.25, k equals 0.25. So you're multiplying each coordinate by 0.25. And I think another one was 1/3. Okay, so that is how that works. Okay, and this notation here is going to be important for identifying kind of the big idea of dilations. Okay, now let's take and apply this in a different setting. And I say a different setting. What I mean is we're going to look at some Get More math. So you guys did some big ideas math yesterday. We're going to do some Get More math today. Okay, so we're going to take a look at that. And we're going to take a look. So there's some things that we noted. Number one, dilations performed give us an image that is similar. So we have a similar relationship. Okay, they have the same shape, different size. Okay, so that's going to be number one. That means that the angles are congruent, and that is a symbol for congruent, and that means the sides are proportional, but they are not congruent. Okay, not congruent, proportional. Okay, let's say some other things that we should know here. And I'm not even reading the problem yet. The image xy would map to then kx, ky, and so that is what the new thing will be. And then if anything else comes up, we'll add that. All right, so we could see here, we can identify, because that's prime, that this larger one is the image. This is the original. It does not have the prime. So this is the original, and the outside one is the image. We can see that it is an enlargement. Now I can tell all of that without even reading the problem yet. And me looking at it and determining that now helps me with the problem. Which of the one of the following statements is false? Now please be reading. I was doing this the other day, and I just wanted to get an idea of what the problems were, and I kept missing them because I wasn't reading that. So false means that it's not meeting the criteria that I just listed up here. It's the angles are not congruent, the sides are not proportional. Okay, we said sides are not congruent in similarity. Maybe it says they are, whatever. Okay, so stuff like that. Side ij is congruent to side I prime. Oh, you know what? I think we may have just found our first one, because we know that the side of the original is not congruent to the side of the image. So I'm going to say that this is false, but let's look at the other ones. The ratio of ij to I prime j is equivalent to the ratio of jk to j prime k. So what that's just meaning is that ratio that we're doing, the ratio should be same for all sides, just so you know. If the scale factor is 2, it's going to be 2 for all the sides. So the ratio is going to be same for all of the sides. So this is a true statement. So we're going to say yes on that. But we're not looking for true, we're looking for false. But we're going through all of them just to make sure I didn't mess up. Angle J is congruent to angle J prime. Yes, we've already determined that the angles are going to be congruent. All corresponding sides are proportional. Yes, that's part of the similarity, right? So we know that's true. We are looking for false. So A is going to be our true answer here. Okay. And so we take all the things that we know about this and we apply that. Which statement is true about triangle VWX and triangle V prime W prime X prime? They look like they're the same thing. So how do we know that? Okay, so we don't just say, well, they look the same. We count. 1, 2, 3, 4. V prime W prime is 4. VW, 1, 2, 3, 4. That's 4. They're the same thing. Okay, so same shape, same size. Okay, sorry for that interruption. So same shape, same size, similar, but because we could say that they're proportional, we could say that so the sides are proportional and the angles are congruent, are congruent, yeah. And we could say they're congruent because the sides are congruent and the angles are congruent. So we could say both are true. That's a different one. It's good that it's showing up here on the examples. Okay, which one of these is true? So I have, obviously we have a dilation. It's an enlargement because this is the image. This is the original. So I know that they should be similar, which means I know that the angles, there's my symbol for angles, are congruent and the sides are proportional. Okay, so let's take a look at that. And that, I don't know why I put an E on the end of similar. Don't ask. Okay, so the figures are neither similar nor congruent. And then I go back and say, okay, it's asking for true because I don't want to fall in that trap again. The figures are congruent but not similar. Nah. The figures are similar and congruent. Nah, because to be both similar and congruent, the sides would have to be the same, like on number 2. The sides are similar but not congruent. Ding, 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 ding. Okay. So we don't a dilation gives us similar. A dilation doesn't necessarily give us congruent. In fact, in most cases, a dilation would either make it bigger or smaller. All right, let's take a look at this here. So we have an original, okay, and it says triangle PQR is dilated to form triangle P prime Q prime R prime. The length of PQ prime measures 10 units. So our image is going to be 10. So I'm just thinking, I don't even know what it's asking. I'm just thinking, so that means that the original, what would the original be? I don't know. Just says it's dilated. So we don't know what that's going to be. 1, 2, 3, 4, 5. Oh, it's 5. So we know there's a scale factor of 2, right? Why do we know it's 2? Because it's the ratio of image over original. So that's 10 over 5. So the scale factor is 2. All right, it says which of the following statements is true? Angle P measures 45, P prime, because of corresponding angles. But we already know P prime. Oh, no, we don't know P prime. Okay. Because we know the corresponding angles of PQR and P prime Q are congruent. We do know that's true. Yeah. Okay, so, but I'm going to go through this. So let's look. P prime measures 90 degrees. No, because P was 45. How could P prime be 90, right? So that's not true. C. PQR is congruent to triangle P prime, Q prime, R prime. Okay, so P prime, triangle PQR is congruent to prime. No, triangles aren't congruent. No, because we see that this is 5, this is 10. They're not congruent. They're similar, right? So this is a no. There should be similar. And then all corresponding sides are congruent. No, because all corresponding sides are proportional. Okay, so that's out. So A is truly our answer. Yay. Okay, let's look at this next one then. Let's look at the next one then. Get over here. Next one. Okay, so triangle UVW is shown on the coordinate grid. As a center dilation, use the rule XY yields 4x, 4y. Okay, so what you need to know about this is when it says XY, and it's kind of actually says maps too, but don't worry about that. 4x, 4y. It's telling you the k is 4. Okay, so that means we're taking all of these coordinates and multiplying by 4. Okay, now because it's saying that's greater than 4, I make some conclusions. I draw some conclusions. One, this is k is greater than 1, so it's an enlargement. I might be able to tell something about side length if they give it to me. They haven't, so let's go ahead and read. Let's go from there. Okay, U prime, V prime, W prime is smaller. No, we just said it's an enlargement. In fact, let's just get rid of the 2 of the smaller ones. Okay. The scale factor is larger than 1, so it's an enlargement. Okay, U is larger than the triangle because the scale factor is less than 1. Meh, it's greater than 1. is larger, it's going to be C. Okay. All right, so that's a type of problem that you have to see. Okay, I've got circle 1 and circle 2. Circle 1 was dilated to create circle 2. So this is the image. So we'll put a little prime there. Okay, so it is an enlargement. So I think then I'm thinking through, that means K has to be greater than 1. An enlargement, K is greater than 1. So that means that, and I kind of peeked ahead, that means that when I'm multiplying my XY, get my arrow, the number I put in front of XY has to be greater than 1. Let's take a look at this down here. Okay, and it's multiplied, right? So it's K times X and K times Y. So when I'm looking at this, I have a times here. Okay, I do not have a times. I have a plus here, so it's not going to be that. This is not a times, so that's going to be gone. And then on this one, I have times here. And which one has a K that's greater than 1? D. K is 2. It's greater than 1. This one is K is 1/2, which is less than 1. Okay, so that's why A does not work. Okay, so we really have to kind of define that and see that. Okay, a pentagon is graphed on a coordinate grid and dilated by a scale factor of 3/4 with the origin and the center dilation. The vertex of the original pentagon was located at 7,4, which order pair represents the vertex of the new pentagon after the dilation. Okay, so anytime that we have perform a dilation, we take that original here and we're going to multiply it by 3/4. So 3/4 times 7 and 3/4 times 4. Well, that's easy. That's 1. So that makes that 3. And I like seeing these easy ones. Okay. And I'm not going to do this next one. I want you guys to see something. I mean, 3/4 of 7 is obviously going to be less than 7, right? Half of 7 is 3.5. So it's going to be somewhere between 3.5 and 7. But you don't even need that much thinking, because if you just look at this here real quick, doing a cross cancel and doing that math, there's only one that has that. Okay, so it's going to be A. And the one in front does match my further thinking in that it has to be between 3.5 and 7. But, look for little things like that. Sometimes finding the simple eliminates all the rest. A quadrilateral is graphed on a coordinate grid, then dilated by a scale factor of y, with the origin as the center dilation. If the vertex of the original quadrilateral is negative 3, 1, then we know, and I'm just leaping here, that if the scale factor is y, then I'm just simply multiplying each of these by y. And I make that leap before I get confused by all the options. So I write it out, kind of think, okay, so it's got to be, each one of those has to be times y. Okay, so I'm looking here, and it says which ones I'm not seeing. Okay, so this is times y. But let's look at the rest. This is plus y. Nah. This is divided by y. Nah. This is plus 1 over y. That doesn't even make sense. So we are going to stay with A, that we are right. And when you are doing some of these tests, these all have one answer, but you're going to run into tests that say mark all that apply. So it's important to learn to go through all the options, even if you think A is right. ABC was dilated. Okay, so all right, so we see that it's an enlargement because the primes are bigger, blah, blah, blah. Which one would represent? So if it's an enlargement, K has to be greater than 1 as I'm looking at this, and it's going to be, it should be KX, KY, right? Okay, so let's look at these options. First of all, we eliminate the ones that are not times. So that's not times, so this is gone, and that's not times, so this is gone. And just do that off the top. Has to be greater than 1 because it got bigger. So this is 0.5 and this is 2, so C. Okay, we did do one like this, so that's good. We can move on. Pentagon, so we got 5, negative 4. We got a scale factor of 2/3. So times 2/3 times 2/3. And this one's going to be a little bit uglier. So this is, put it over 1. This is 10/3. This is negative 8/3. 3 1/3, 2 and 2, negative 2 2/3. So let's look at those. Okay, so this is 6.5. That's gone. That's gone. That's gone. So it's got to be A. Okay. Once I see it's 3 1/3, then I can see A is right because the other ones are way off. Okay, so that is how we do these problems. That's 10 problems, so it gives you an idea of what this looks like. Watch the video several times if you need to, come back to it. And that's what I got. I'll post both of the notes and the video up, and that's what we're going to be working on today. Thanks.